Hello and welcome to Mrunal's Math Tutorials. Today we're going to look at Paper 5 Probability and Statistics, May June 2020. Hello and welcome to Mrunal's Math Tutorials. The first question is about coding. For n values of variable x, it is given that sum of x minus 50 is equal to 144 and sum of x is 944. We need to find the value of n. First of all, let us understand what is the coding given to us. Let us use a variable y to represent the coding. Y equal to x minus 50. This is the coding that has been given to us, right? When we have y equal to x minus 50, we can always write the mean of y is equal to mean of x minus 50. So, this information over here is nothing but because we represented x minus 50 as y, we can say that this is sum of y and we have sum of x as well. To find the mean, it's going to be a sum of y, which is this value 144 divided by n. To find the mean of x, it's going to be sum of x, which is 944 divided by n minus 50. Multiplied throughout by n gives us 144 equal to 944 minus 50n. Let us try and make n as the subject. So that's going to give me 50n equal to 944 minus 144. So 50n is equal to 800. N is going to be 800 divided by 50, which is 16. When you use this method, you're never going to get any coding question incorrect. Let's move on to the next question. So here we have the second question. We have a total of 500 students were asked which one of the 4 colleges they attended and whether they preferred soccer or hockey. So these are the different colleges and we have soccer and hockey. All right, so we need to find the probability that a randomly chosen student is at Canton College and he prefers hockey. So look at Canton College and look at hockey underneath. So we can see that is 56. So this is going to be 56 out of the total. The total is 500, which has been given over here, and you can see it over here as well. Now, you may leave your answer here, or you may write it in simplest form, which would be 14 out of 125. Part B, find the probability that a randomly chosen student is at Trevor College given that, let's highlight that, given that he prefers soccer. So let's try to remember the formula that we're going to use for given that. Probability of A given B, you read this as given. This is equal to probability of A intersection B divided by probability of B. So now, what is the intersection between the Trevor College and soccer? So we go into the table, Trevor and soccer. So the intersection is 120. Yeah. So 120 out of the total, which is 500. And probability of B, which is going to be soccer, Yeah, so soccer would be, the total for soccer is 280. So this is going to be 280 divided by 500. So again, A is your Dever College and B is playing soccer. So now we can see that we can cancel the 500s. So you're left with 120 out of 280, which is going to be equal to, in simplest form, 3/7. Yeah. Part C, one of the students is chosen at random. Determine whether the student prefers hockey and the student is at Amos College or Ben College are independent. Right. So we need to determine whether these two events, that is playing hockey and the second event being the student is at Amos or Ben College, if they are independent. Now, let's come back to the rules for being independent. What are the rules for being independent? So, if two events are independent, let's say PA and B, if they are independent, then their product is equal to their intersection. Yeah? So, here we need to find the probability of playing hockey, the probability of being in Amos or Ben College, and we also need to calculate playing hockey intersection with being in Amos or Ben College. Once we calculate that, we are going to test this. If the product is equal to the intersection. So what is the probability of playing hockey? Let's look up in the table. Playing hockey, so we have playing hockey is 220 out of the total 500. So we can say that the probability would be 220 out of 500. You can leave it here, no need to simplify. The probability of being in Amos or Ben College, so we are just simply going to add Amos and Ben, both of these. So 86 plus 156, which is 242. We added these two. 242 out of 500. And now we need to find the intersection between playing hockey and being in Amos or Ben College. So we're just going to add up these two because this is Amos and Ben, and add up these two. So 32 plus 72, that's going to be 104. So the intersection is 104 out of the total, which is going to be again 500. So let us try to calculate what's the product of PH times PA or B. It's going to be 220 over 500 times 242 over 500, which is going to be 1331 divided by 6250. As you can see that these two values are not equal or not the same, so you must write a statement here. Since PH times PA or B is not equal to the intersection, which is PH intersection A or B, events are not independent. You have to write the statement to get the final accuracy mark. Okay. So that's it about question 2. Let's look at question 3 now. So two machines A and B produce metal rods of certain type. The lengths in meters of the 19 rods produced by machine A and 19 rods produced by machine B are shown in a back-to-back stem and leaf diagram. So this is the key. The key is very important. So 22 and 4 means 0.224. This is very important. And 722 means 0.227. Okay, this is extremely important to read the key. Otherwise, all your calculations are going to be incorrect because you would be reading the numbers incorrectly from the stem and leaf diagram. Now we need to find the median and interquartile range for machine A. So we're looking at machine A, which is over here. So we know that there are in total of 19 entries. So the median is going to be, we're going to use this, since it's a discrete data, we're going to use n plus 1 divided by 2. So 19 plus 1 divided by 2, 20 divided by 2, which is the 10th value. So 10th value is going to be your median. So your median is going to be then, count the 10th value. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the median is this value. So it's going to be 0.238. To find the interquartile range, IQR, we need Q3 and Q1. So Q3 is going to be the median of the lower half. Because this is a discrete data, it's going to be median of the lower half. That means how many values before the median. You can count them. So we have 4 here, 5, 6, 7, 8, 9. So 9 values before. So what is going to be the median of 9 values? It's going to be 9 plus 1 divided by 2. It's going to be 10 divided by 2, which is the 5th value. Yeah. So Q1 is going to be equal to the 5th value, which is, let's count. So 1, 2, 3, 4, 5. This is going to be your Q1. That is, let's highlight it with a different color. This is going to be your Q1, which is 0.231. Likewise, the 5th value after the median. So you count from here, 1, 2, 3, 4, 5th. 5th value after the median is going to be your upper quartile. So this value is going to be your upper quartile. Yeah, 1, 2, 3, 4, 5th value. So that's going to be 0.245. And hence your IQR is going to be the difference of the two values, which is 0.014. Right? So whenever you have discrete data, you got to find the medians of the upper and lower half. That is going to give you the quartiles. That's it about question 3, part A. Let's look at the part B. Now, it is given that for the machine B, the median is 0.232 and Q1 is 0.224, Q3 is this. We need to draw a box and whisker plot for both A and B. So here we need to draw the box and whisker plot for both A and B. We have calculated the values for machine A, the median and the lower quartile and upper quartile. So let's write it down. So for machine A, median was 0.238, Q1 was 0.231, and Q3 was 0.245. So we need to set up a scale and also label the diagram correctly. All right. So let's set up a scale. Now we're talking about the x-axis. The x-axis is about, this is the length in meters. We can read it over here. It is the length in meters. Yeah. So we label the x-axis as length in meters. Yeah. And let's choose a decent scale. We also need the minimum values for box and whisker plots and the maximum value. So the minimum value for machine B is 0.211. And the maximum value is the last value here, 0.256. Whereas for machine A, the minimum value is, you can see over here, there isn't any number, so it's going to be 0.220. And the maximum value is going to be the last value here, which is 0.254. All right, so I see that this is the minimum least value that I need to have. So I may want to start with 0.210. So 20, 30, 0.240, 0.250, 0.260. I think this is a good scale, right? Now let us start marking. The first one we have over here is, let's do machine A. The minimum is a 0.220, and then the maximum is a 0.254. So I've marked the minimum and maximum. Now I will be marking the median. The median is 0.238. 0.238 is going to be over here. That's the median. Q1 is 0.31. And Q3 is 0.245. Complete the box. And join the whiskers. And label this to be machine A. Let's do machine B. The minimum value for machine B is 0.211. So it would be, let's say over here. Then the maximum is 0.256. It's going to be here. The median is 0.232. 0.232. Lower quartile is 224. Upper quartile is 0.243. Complete the box and join the whisker. And remember to label this as machine B. If you label the axis, you have labeled the diagrams, you get full marks. Now, hence make two comparisons between the lengths of rod produced by machine A and machine B. We're going to make use of the median and IQR to compare. Yeah, so you can see that the median of machine A is higher than the machine B. So we would say that you have to write it in context. So lengths of rods produced by machine A, copy the sentence from the question itself. Lengths of the rods produced by machine A are longer than that of machine B. That's the first comparison. The second comparison will be from the IQR. If you look at the IQR, the difference between the upper and lower quartile, machine A, it's smaller than machine B. Machine B is much higher. So you can say that if you want to write with machine A, you say that the lengths of rods produced by machine A are less spread out, because IQR tells you about the spread. So IQR for A is smaller than that for the B, so we would say that it is less spread out. Let's go on to question 4. Now in question 4, this is about normal distribution. Okay, question 4 is about trees in radian forest are classified as tall, medium or short according to the heights. The heights can be modeled by a normal distribution with a mean of 40 and standard deviation 12. Trees with height less than 25 meters are classified as short. Now here we have a normal distribution. So let's remind ourselves, how does normal distribution look like? The notation is X is normally distributed with mean and variance. So here the mean is 40 meters and the standard deviation is 12. Remember, standard deviation is 12, so it is square root of variance. So you should write this as a 12 square, right? Okay, now we need to find the probability that the randomly chosen tree is classified as a short tree. So in the question it's been given that if the height is less than 25 meters, it is classified as short tree. So we would do probability of X less than 25 meters. Remember, we need to standardize the values. So we need to make the mean 0 and the standard deviation 1. So we are going to use the formula probability of z-score less than x minus mean over the standard deviation. So it's going to be z-score less than 25 minus 40 over the standard deviation, which is 12. So that works out to be 25 minus 40 divided by 12 is probability of z-score less than negative 1.25. If it is negative, so you're looking at, if you sketch it, this is the mean with 0, this is negative 1.25, you're looking at this area. By symmetry, it is same as this area, so it's going to be 1 minus probability of z-score less than the positive. Yeah, so 1 minus phi of 1.25. So look up your table and read the value for 1.25. What is the value for 1.25? So it's going to be, from the table you get 0.8944. So 1 minus that value is going to be 0.106. So that's the probability of a randomly chosen tree to be classified as short. You have to give your answers correct to 3 significant figures. B, what do we have? Of the trees that are classified as tall or medium, 1/3 are tall and 2/3 are medium. Show that the probability that a randomly chosen tree is classified as tall is 0.298, correct to 3 decimal places. All right, in part A, we calculated that the probability of a tree being short is 0.106. That means the rest of the trees are either medium or they are tall. So what are the rest of the trees? 1 minus 0.106, that is the probability, which is going to be equal to 0.894. Now we need to show that the probability of a randomly chosen tree being classified as tall is 0.298, and we also know that 1/3 of the trees are tall. So we have the probability. So for tall, it is going to be 0.894 multiplied by 1/3, which is going to be equal to 0.298. In part C, find the height above which the trees are classified as tall. So we know the probability of the tree being classified as tall is about, so this is the mean, is about 0.298. That means around 30%. So let's say this is the probability, which is 0.298. So the probability is equal to 0.298. We need to find this value, the z-score, which will tell us the height above which the trees are classified as tall. So we have to find probability of z less than z-score equal to 0.298. So of course this is less than 50%, so we have to do 1 minus 0.298, yeah, and then find the 1 minus 0.298, which is going to be 0.702, and then to find the z, we are going to do inverse normal of 0.702. So in your 19, put this as 1. You know, how do I get that? I get that from here. This is basically the same z-score, which is going to be 944. So after rounding to 3 decimal places is 0.298. So we need to calculate 0.7019. That would be more accurate. So if you look up your table, phi inverse, you're going to get it as 0.53. So once you have the z-score, use the formula. Z-score is x minus mean over sigma. So 0.53 equal to, we need to find the value of x. We know the mean is 40 and standard deviation is 12. Cross multiply and add 40. So that gives me 0.53 times 12 is 6.36 plus 40 gives you the height as 46.36, which can be rounded off to 46.4 meters. Right? In question 5, you have a fair three-sided spinner which has sides 1 to 3, a fair five-sided spinner which is numbered 1, 1, 2, 2, 3. Both the spinner are spun once. For each spinner, the number on the side on which it lands is noted. The random variable x is larger of the two numbers if they are different, and it's a common value if they are the same. All right. So here what is happening is you have two spinners. I'm just going to make a table for you to understand. So spinner 1 has 1, 2, and 3. The other spinner 1, 1, 2, 2, and 3. So how are the scores recorded? The scores are recorded. So the random variable x is a larger of the two numbers if they are different. And if they are the same, you write down the same value. So for 1 and 1, you would write 1. For 1 and 2, you will write the larger value, which is 2. For 1 and 3, you would write 3. Again, the same thing. For 2 and 1, you would write 2, 2, 3. You would write 2, 2, 3. And here you would write 3, 3, and 3. So basically the outcomes that you have is 1, 2, and 3, right? So that's all the possible outcomes you have. So if you make a table, which would be the second part, although yeah, that would be draw up a probability distribution table, that would be second part. Now let us see what is the question asking us to do here. The question is asking you, show that probability of x equal to 3 is equal to 7 over 15. All right, so in my table that I have drawn up, how many 3's do I have? 1, 2, 3, 4, 5, 6, 7. So I have 7 out of the total outcomes. You have on this side you have 5 and this side you have 3. So the total outcomes is equal to 15. Yeah. So the method mark would be for you to draw up this table. If you don't draw up the table, you do not get the full marks. Now let's draw up the probability distribution table. The only values x can take is 1, 2, and 3. And the probability of x equal to x is, how many 1's do you have? You have 2 out of 15. How many 2's do you have? Look up in your table. 1, 2, 3, 4, 5, 6. 6 out of 15. And that is 7 out of 15, which has been calculated before. Right? Now we need to find Ex and the variance of x. Let me just copy this table down there. So we need to calculate Ex. Remember, Ex is equal to sum of x times p, and the variance of x is going to be sum of x squared times the probability minus Ex bracket square. Okay, so let's find Ex first. Ex is just going to be 1 times, just multiply the x values with the probability. 1 times 2 over 15 plus 6 times 2 times 6 over 15 plus 3 times 7 over 15. This turns out to be 2 over 15 plus 12 over 15 plus 21 over 15. That is going to be 7 over 3. To find the variance, you square the x values and multiply by the probability. Each x value is being squared and multiply by the probability, and then you minus the answer of part A, the mean square. Let's calculate that. So it's going to be 2 over 15 square. So it's going to be again 2 over 15. 4 times 6 is 24 over 15. 9 times 7 is 63 over 15. That is 89 over 15 minus 49 over 9. That works out to be 22 over 45, which is 0.489, correct to 3 significant figures. Find the number of different ways in which 10 letters of the word summertime can be arranged so that there is E at the beginning and E at the end. Alright, this is permutation and combination. We need E at the beginning and we need E at the end. So let's cross that out, cross the E's out, and you're left with the rest, which is SUMMRTIM. So these positions are fixed. Yeah, you have E at the beginning and E at the end. So the remaining we need to arrange. So we have 8 different items to be arranged, and there are some repetitions, so we got to divide by the repetitions. I can see that we have 3 M's repeating. That's all. So that's going to be 8 factorial divided by 3 factorial, which is 6,720. That's question 6A. Part B, find the different number of ways in which the 10 letters of the word summertime can be arranged so that the E's are not together. So how many E's do we have? We have 2 E's. They are not together. Remember, it's just not together. It's not like not all together. There are many ways that you can work with this. If they are not together, the easiest way to do is to find the total number of arrangement. Total arrangements is going to be, you have 10 words, 10 factorial, out of which 3 M's are repeating and 2 E's are repeating. This turns out to be 302,400. 302,400. And if the E's are together, put them together. So if the E's are together, count them as 1. So you have SUMM, then E together, count them as 1, RTIM. So how many items you have to arrange? So you have here 1, 2, 3, 4, 5, 6, 7, 8, and count this as 1, which is 9. So 9 items to be arranged. 9 factorial divided by the repetition, that is the m's repeating. Remember, you don't divide by 2 factorial for e because it's counted as 1. So this is equal to 60,480, and is not together, is just going to be 302,400 minus 60,480, which is equal to 241,920. Part C. The 4 letters are selected from the 10 letters of summertime. Find the number of different selections. If the 4 letters could include at least one M and exactly one E. So how many M's do we have? We have 3 M's. And how many E's do we have? We have 2 E's. But we have to include only one E, exactly one E, and at least one M. At least one M means you could include more than one M. So the different selections for the 4 letter words would be so let's say you surely have to select one E, and let's say we select one M, or it could be one E, 2 M's, or it could be one E and all the 3 M's. So these are the different possible scenarios that you can have. Now the remaining letters, if you remove the 3 M's and 2 E's, total of 5. If you remove that from 10, you're left with 5 letters. From 5, you choose 2. From 5, you choose 1. And here from 5, you choose nothing. So that's going to be equal to 5 choose 2 is 10. 5 choose 1 is 5. 5 choose 0 is 1. So there are total 16 ways. A common mistake would be some of the students may write, oh, I have 3 M's, so from 3 M's you need to choose 1. So they start writing 3 choose 1. That is not correct because all the M's are identical. So you need to cross that out, cross the M's, all the M's and all the E's from that, and you do the selections. So you would write 3 choose 1 for the M's if they were all different M's. I mean different people, for example. Yeah. So since they are identical, you do not consider it. So it will be only 16 ways. Question 7. On any given day, the probability that Moina messages her friend Pasha is 0.72. Find the probability for a random sample of 12 days. Moina messages Pasha on no more than 9 days. So I see that we have number of days given to us. We also have probability of success over here. So it is clearly a binomial distribution because the number of days are given to you. So it is binomial 12 days and probability of success is 0.72. So Fiona messages Pasha on no more than 9 days. So probability of X, no more than means less than or equal to 9. So we have 12 days, so we can easily do 1 minus probability of less than or equal to. So less than or equal to 9 means 1 minus probability of 10, 11 and 12. So let's apply the binomial distribution formula from the formula booklet. NCR. So 12 for this, it's going to be 10. 0.72 to the power of 10, and 1 minus 0.72, which is 0.28 to the power of 2. Likewise, NCR 12C11, 0.72 to the power of 11 and 0.28 to the power of 1. The last one, 12C12, 0.72 to the power of 12, 0.28 to the power of 0. Not necessary to write, but I'm just writing it. 1 minus, let's calculate the individual values. You have marks for that step, so you need to write down the steps properly. So 12C is 10 times 0.72 to the power of 10 times 0.28 square. This is going to be 0.1937248 plus 12C11 now. It's very easy, just change on your calculator. Remember, this step is going to give you marks. The method marks are going to come from this step. Method and accuracy marks. Times to the power of 1. This is going to be 0.0905725. I mean, 4 to 5 decimals after 4 to 5 decimal places is enough to get the accurate answer. 12C12 then, that gives you 0.019484. And now let's do 1 minus all of that on your calculator. 1 minus 0.19372468 plus 0.090575 plus 0.019484. That gives me correct to 3 significant figures, 0.696. That's about it for part A. Miona messages Pasha on 1st of January. Find the probability that the next day on which she is going to message Pasha is 5th of January. All right, so she has messaged Pasha on 1st of January. The next time she is going to message him is going to be on the 5th of January. So 1st of January is over. We have 2nd of January, 3rd of January, 4th of January and 5th of January. So we know that on the 5th of January she is going to message him, so that's 0.72, and the rest of the days she is not going to message, right? So it's going to be 0.28 to the power of 3 times 0.72, which is 0.0158. Remember, Miona messages Pasha on the 1st of January. Find the probability that the next day on which she is going to message. So next day. So you finish this day. So you start from 2nd, 3rd, 4th and the 5th. Yeah. So from 2nd to the 4th she did not message, and on the 5th of January she does message. So that's about it. Question number 7. Part C. Use an approximation to find that in any period of 100 days, so we have been given a period of 100 days, Miona messages Pasha on fewer than 64 days. Right. So we need to use the approximation over here. So we had a binomial distribution at the start. So binomial to normal is going to be, so we had binomial distribution at the start, NP. Now it's going to be normal distribution with mean and variance. So let's calculate the mean. The mean is going to be NP. As we know the formula for binomial, the mean is going to be NP. So it's going to be 100 times 0.72, which is 72. And the variance for binomial is going to be NPQ, which is 100 times 0.72 times 0.22. That works out to be 20.16. Now we change it to normal distribution. So let's choose a different variable. We can't use the same one. Let's call it as y. So y is normally distributed with mean 72 and variance 20.16. Yeah. So we need to find probability that Miona messages Pasha on fewer than 64 days. So probability of y less than 64. Now, since we are using an approximation from binomial to normal, okay, normal distribution is continuous, so we need to make this value continuous. So we are at 64. Less than 64 is, if you make it continuous, it's going to be 63.5, and the upper limit is going to be 64.5. So we want less than 64. So that means it's going to be everything on this side. So it's going to be probability of y less than 63.5. So the z-score would be less than 63.5 minus the mean over the standard deviation, which is square root of variance. So this works out to be So remember to do the continuity correction. So this works out to be negative 1.893. 3 decimal places is required. So this is same as 1 minus phi of 1.893, which is equal to, read from the table, what is the value of 1.893? 1 minus 0.9708, which is 0.0292. And that's about this question and end of the paper. All right. Thank you for watching the tutorial. Make sure you like, share and subscribe my channel.